All right, this podcast is going to be about physical and chemical changes, and I'm recording this outside, and my dogs are playing out here, so if you hear some weird noises, that's what's going on. The puppy dogs are playing, and there might be cars going by, and it is a little bit windy out here. But these notes are going to go, they're going to be Cornell style, and they're going to go on page 39 in your interactive notebook. Again, the title is Physical and Chemical Changes. So we've been talking about properties of matter. We've been talking about physical properties and chemical properties, and we spent quite a good deal of time talking about the specific physical property of density. But now we're going to turn our attention to changes that matter undergoes. So all these different types of matter we've been talking about can also change. And there are physical changes and there are chemical changes. First, we're going to talk about physical changes, and here's a definition. A physical change occurs when the substance undergoes a change, but the change does not mean that its identity has changed. It's still the same kind of matter. Okay, so it's undergone some kind of change. Maybe it's been cut or crushed or even dissolved, but it's still the same matter. It hasn't changed its identity. The form or appearance can change, but that substance still has its same properties. It hasn't changed into something else. For instance, this piece of paper that's pictured here, I could crumple it, I could fold it, I could even cut it, I could wet it, and all of those changes, it will still be a piece of paper. It hasn't turned into anything else. It's still just a piece of paper. That is a definition of a physical change. Here are some more examples of physical changes. You might want to write at least a couple of these down. Melting is a physical change because although it changes its state from solid to liquid, it's still the same matter. So if you melt wax, it's still wax. It's just melted wax now. Boiling, same thing. Freezing, same thing. You can cut something. You can dissolve it. So you can dissolve sugar into water. And if you dissolve sugar into water, the sugar is still sugar. It's still in there. It still tastes sweet. It has its same properties. Crushing something, breaking something, or molding something like Play-Doh. You could mold Play-Doh. You could crush these cars. You could carve this watermelon into a really cool spider shape. But all of these are physical changes because the matter hasn't changed. The watermelon isn't a spider. It hasn't changed into a spider. It's just been carved into the shape of a spider. It's still a watermelon. So it's a physical change. Now, the other type of change that matter can undergo is called a chemical change. Chemical change is different because a chemical change happens when a substance ends up changing into something else. There's such a dramatic change. It's matter becoming a new kind of matter. So when you have a chemical change, what you end up with is something totally different than what you started with. And usually it's very difficult to reverse it. It might be impossible to reverse it. You can tell a chemical change has happened if the physical properties of the substance has changed. For instance, you could take that piece of paper I talked about a minute ago and you could burn that piece of paper. If you burn it, that's a chemical change. What you end up with, you wouldn't call paper anymore. We call it ash. And ash has very different properties than paper. You can't write on ash. It would be very difficult to write on ash. It's very crumbly. It's a different color. It's completely changed into something new. The other name we have for a chemical change is a chemical reaction. So if we say that a chemical reaction has occurred, then we say a chemical change has occurred. They're the same thing. Now, there are several signs that a chemical change has occurred, and I want you to learn these signs, so make sure you write these down. The first sign that a chemical change has occurred is a change in color. And this is a spontaneous change in color. This isn't that you colored it, you painted it, or something like that. That's not a chemical change. But if you suddenly have a change in color when you mix a couple of chemicals together, for instance, when you burn the paper, like I said, you end up with something completely different color. You didn't paint it, you didn't dye it, it just turned color. A lot of times when you mix a couple of chemicals together, they change color. For instance, we did the lab we did last week. We did iodine with the cornstarch, and it spontaneously turned that purple color or that black color. That would be an example of a chemical change. The second sign that a chemical change has occurred is the production of a gas. We usually see this as bubbles. Sometimes you don't see the bubbles if it happens to be a gas coming out of something that's not a liquid, but usually if you see bubbles, if there's a gas being produced of some kind, then we know a chemical change has occurred. Another sign a chemical change has occurred is any kind of a change in energy. If something lights up spontaneously, like these glow sticks, if something gets really, really hot, or even just a little bit hot, or if something gets cold or really, really cold, any kind of change in energy is a sign that a chemical change has happened. And so we're going to do some experiments, and you probably have maybe already observed some experiments where things get hot or things get cold or things light up. This is a sign of a chemical change. The fourth sign of a chemical change, that a chemical change has occurred, is something called formation of a precipitate. A precipitate. This is when you have the sudden appearance of a solid when you mix two liquids together. And this may not be something that you have had personal experience with, but I'll do some demonstrations in class. But in this picture, you see there's a clear liquid being poured into another clear liquid, and suddenly, lo and behold, this yellow solid appears like out of nowhere. Okay, this is the formation of a precipitate. That yellow solid is called a precipitate. So anytime you have two liquids, suddenly a solid appearing in there, that's a sign that a chemical change has occurred. Finally, this is the last sign that a chemical change has occurred. This is production of an odor. Okay, if something gets smelly, that's a sign that a chemical change has occurred. Something gets smelly, like these fruits and vegetables, you can imagine they probably don't smell very good, and rotting is a chemical change. So anytime you get the production of an odor, some kind of smell coming out, might be a good smell, might not be such a good smell, but either way, that's a sign that a chemical change has occurred. Here are some examples of other chemical changes, and these all would show one or more of those signs that a chemical change has occurred. You might want to write a few of these down. First, a reaction with an acid. Anything that when you see some kind of a reaction going on with an acid, bubbling with that, or something like that, color change, that's a chemical change. Combustion, okay, also known as burning. When something burns, that's a chemical change. Corrosion is a sign of is an example of a chemical change. An example of that, of course, being rust forming on iron. Digestion is a chemical change, and we could talk about that in class. Fireworks are a chemical change. Photosynthesis in plants, and the souring of milk. And you could think about all those signs that I just talked about, and how each of these examples shows the signs of a chemical change. Now, I already mentioned how a chemical change is also known as a chemical reaction. And I do want you to know a little bit about the rate of chemical reactions, because different things affect how fast a chemical reaction occurs, how violent a chemical reaction occurs. For instance, temperature. If you have a higher temperature, usually a reaction will happen faster, the warmer the temperature. Sometimes if you get too high temperature, it won't happen at all. But if a cold temperature, the reaction will happen slower. A warmer temperature, it happens faster. Concentration. The more concentrated you have of the matter, of the chemicals that are reacting, usually that means it's going to react faster. So a chemical change will happen faster if you have more of it, more intense concentration. And finally, surface area. If you have a big chunk of something, it's going to react slowly or change slowly, compared to a smaller piece of something. It's going to change much more quickly. Okay? Okay, and this is the last thing you're going to need to write in your notes. There is a scientific law that goes with talking about changes in matter, and this is the law of conservation of matter. And this scientific law says that matter cannot be created or destroyed. You can't get matter from nothing. It always comes from somewhere. So what ends up happening in these chemical reactions, when you get a new substance forming, it formed from the other substances. So all that's happening is the matter is being rearranged. Matter's converted from one form to another. So there's a rearrangement of the matter whenever there's a chemical reaction. And here's an example. If you combine methane, which is CH4, that big black ball is the carbon, and then the white ones are the hydrogens. If you combine that with oxygen molecules, which are two oxygen atoms glued together, those are the red ones there. When you combine methane and oxygen, there's combustion that happens. It'll burn. And when it burns, what's happening is there's a rearrangement of the atoms. The matter gets rearranged. You don't lose any. So you notice on the left-hand side there with methane, we have one of those black balls. On the right-hand side, now that carbon, the black ball, has been moved, and now it's attached with some oxygen, and that forms carbon dioxide, CO2. So you have two red ones attached to the black now, and the white ones, there were four of them on the methane, and now they have combined with the other two oxygens to form two water molecules. So when you burn methane in oxygen, you end up with carbon dioxide and water vapor. Water vapor, so water in the gas state. And so you see you haven't lost any matter. It may seem like you've lost matter because you burn that methane, it looks like it's gone. But all that's happened is it's rearranged into forming something new. So you cannot create matter, you cannot destroy matter. All you're doing is rearranging matter. All right, that's all I have for you for today. And I will see you tomorrow. And hopefully you can hear this okay from all my crazy backyard noises.
Made with vodcast Pro.